Okay, this is going to be our first lecture for Math 2300. Now, before I cover any material, let me just say a few things about the class as a whole, okay? All of you, or nearly all of you, are computer science majors. And what we're going to cover is going to be mathematical concepts that are very important in computer science. Now, having said that, let me also say that it is probably not what you're expecting, because the mathematics that we're going to be doing is not going to be a lot of calculation. It is going to be logic, okay? You maybe haven't realized in the past that logic is a mathematical concept. But it is, and it's very, very important for computer science. So this is going to be very, very, very different than any math class you've ever taken. I'm very confident in saying that, okay? Some of you will find it extremely easy, and some of you will find it quite confusing. It all depends upon how logically you think, okay? Now, I can teach you the rules of logic. In fact, that's what we're going to cover, okay? But I can't make you a logical thinker. That's something that is either going to come naturally to you or is going to take a lot of practice. But nobody can make it happen. Like, think of basketball as an example, okay? I can teach you the fundamentals of basketball, but I can't make you a good basketball player. You are either born with natural talent, or you're going to have to practice over and over the fundamentals that I teach you, and practicing them will make you become a better basketball player. That's not me making you a better basketball player. I'm just teaching you the fundamentals. And then you're going to have to practice those fundamentals to get them ingrained into your muscle memory. Okay? But what we're going to be doing is very much like that, but even a little bit harder, because I'm not talking about muscle memory, we're talking about thought patterns. Okay? So I'm going to teach you the rules of logic. And if you are naturally born with a way of thinking that is very logical, then this will seem possibly simple to you. Some people find this very simple, okay? If your natural ways of thinking are not what we would call logical, and by the way, I'm talking about from a mathematical sense. I'm not saying logical like, do you do things that, that make sense, okay? Like, buying that jacket is not logical because it costs so much. That's not what I'm talking about, okay? When I say logical, I'm talking about from a mathematical point of view, which if you have not had experience with it, then you don't even really know what I mean by that yet, but you're going to get it as we go along, okay? But the point is this, the point is that I'm going to cover the rules of thinking logically and making valid arguments, valid logical arguments, okay? And determining whether a statement is true or is the statement false, and things like that, okay? And if you struggle with it, you're going to need to just spend a lot of time with it and really learn the definitions and just do a lot of practice, okay? I can help you, but what I cannot do is I cannot get into your brain and change your thought patterns, okay? It's going to take a lot of practice. Unless, like I said, unless this just comes naturally to you. But calculations you can learn, right? See, that's where this area of math is hard for some people compared to something like calculus, because calculus is computational, and you can learn computations just by memorizing how to do them. Okay, but logic is not something that you do, it's a way of thinking. Okay, so I just want to prepare you for that. Doesn't mean this class is necessarily going to be really hard. In fact, like I said, a lot of you are going to find this class really easy. It all depends on your natural strengths and weaknesses, okay? All right, so let's get started. This is not going to cover too much, but it'll be enough. Okay, we're going to do, I'm going to first of all start at the beginning and define what a statement is, okay? And then we're going to define universal statements, conditional statements, and existential statements, and we're going to put those together in different ways. Okay, the definitions in this class are going to be crucially important. Okay, don't gloss over the definitions and say, yeah, I got the basic idea. All right, you need to know the definitions very, very much by heart. Okay, all right, so here's a word that I'm not going to write the definition down because this isn't a mathematical word, okay? And that is the word sentence, okay? A sentence is exactly what you think it is. You know, you put words together and you form a sentence, okay? That's not a mathematical term, all right? But statement does not mean the same thing as sentence. Okay, and I'm going to write down for you the definition of statement. This is almost the whole entire class is going to be based upon this definition. Here, I was going to abbreviate, but why don't I go ahead and write out the whole word. Okay. A statement is a sentence that is either true or false. And then I'll put in parentheses, not both. Okay, that's what a statement is. Very important concept. Okay. Some sentences are true. And if it's true, then it's a statement. Some sentences are false. And if it's false, then it's a statement. Some sentences are neither true nor false. Might be hard to think of an example of that, but don't worry, I'm going to show you one in just a second. And could a sentence be both true and false? Well, that's actually a really, really deep question. Okay, and we're going to just leave that question on the table for now. Okay, so let me give you an example of two sentences. One is a statement. Actually, I'm going to give you an example of three. And two of them will be statements, and one of them will not be a statement. Okay? So, let me write this down. The car is blue. Okay? That is a sentence, right? Can we agree that that's a sentence? It has a subject and a predicate and all of that. And remember, do they still do that in high school? A sentence diagramming? I'm not sure. I used to love that when I was in 9th grade, though, where you would underline the subject and then underline the predicate and stuff like that. Okay? So that's a sentence. Definitely, no question about it. But that is not a statement. Okay, in 9th grade English class, you would call that a statement. But this is in This is in logic class here, okay? And logically, that sentence is not a statement. And the reason why it's not a statement is because it's not true and it's not false. Now, you might think in your head that it's true or false because in your head you're probably picturing a specific car. But here's the rub. That sentence does not mention a specific car, right? It just says the car. Well, the car could refer to any car. Okay, do you see what I'm saying? So that's not a statement. Okay, because it is neither true nor false. And the reason why it's neither true nor false is because it doesn't tell us, or maybe I'll use the word indicate, sounds a little better. It doesn't indicate which car it is referring to. Okay. Now, if I wrote this, my car is blue. Okay, that is a statement. Because it's either true or false. I mean, I know we could get into being nitpicky and say, well, what if you have more than one car? You know, but let's keep things simple here. Let's pretend I have one car. Okay. If the car that I have happens to be blue, then that sentence is true. If the car that I have is not blue, then that sentence is false. Either way, that sentence is either true or false. And that makes it a statement. So I'm writing, this is a statement because it is either true or false. You could actually check and see if it's true or false. But it's not the fact that you can check it that's important. It's just important that philosophically it is true or it's false, whether you were able to check or not. Okay? And I used the word philosophically, right? Well, you might be interested to know that I said that logic is a part of math. Earlier I said that, and that's true. That's not wrong. It's true. But even bigger than that, logic is actually a field of philosophy. Okay? So what we're doing this semester is actually, to be honest with you, we are going to be studying a branch of philosophy. It's the overlap between philosophy and mathematics, and you get logic. Okay? All right, I said I would give you 3 examples, but actually those 2 cover the whole thing. Okay? So I hope that makes sense. The difference between a sentence and a statement. A statement is also a sentence, but the point is you have a sentence, and not every sentence is true or false. Like the sentence I gave you there. The car is blue. That is neither true nor false. Another way to say it, if you want to, is you could say it's too vague. Okay? And that makes it not be a statement. But this one down here, my car is blue. It doesn't matter whether that's true or false, but what matters is that it's one of those two. It is either true or it is false. Okay? And so that makes it a statement. So that's the first concept that you must get that down, is what do we mean when we say statement? Okay? All right, now I want to cover a few types of statements in particular. Okay? They are called what you see up there at the top of the screen. Whoops, I'm sorry. There we go. A universal statement, a conditional statement, and an existential statement. I want to define those for you. Okay? So a new definition. And everything we do is going to involve statements, because if a sentence is not a statement, then that means it's neither true nor false. Then it does not belong in the realm of logic. You can't study it logically. Okay, so everything we discuss are going to be statements. All right, so definition: a universal statement is a statement that says a certain property. Whoops, I misspelled that. Let me fix it. Is true for every element in a set. Do you know what the words element and set mean? A set is just a collection of things. And the things in that collection are called elements. Okay? So you could say the set of even numbers. Okay, that's a set. And then the elements of that set are the numbers 2 and 4 and 6 and 8 and so on. Okay? We're sort of assuming that those terms are already understood, what element and set are. Okay, now a universal statement is a statement that says a certain property is true for every element in a set. Okay? So I'm going to write a universal statement for you. All cars are blue. That is a universal statement. Okay? Now, you might say, wait a second though, that's not right. I've seen red cars. This is really important to understand. I'm not talking about whether that's right or wrong, except, first of all, I'm not going to use the words right or wrong. Let's use the words true and false. Okay? I'm not saying that that's true. You could say, well, but it says right here, and the definition says true. Okay, that's right. That statement says that a certain property is true for every element in a set. What's the set? The set is, in this case, the set is all of the cars that exist in the world. That's the set of cars, right? And this statement says every element of that set is blue. In other words, every car that exists is blue. You see, the statement is saying that that's true, okay? But the statement itself could certainly be false. In fact, I would argue that that statement right here is false. I could prove to you it's false very easily. All I have to do is show you a car that's not blue. Okay? So do you see what I'm saying? Let me say here, okay? This is a false statement that claims a certain property What's the property? The property is being blue. That's the property that they're talking about. Okay, it's a false statement that claims a certain property, the property of being blue, is true for every car. You see, it's making a claim that something's true, but the claim itself is a false claim. Do you see what I'm saying? Already you might be starting to think, oh, this is getting confusing. Okay, but you got to keep these things separate. Okay, so that is a universal statement about cars, and it is false. The fact that it's false is why I'm calling it a statement, not a sentence, because a sentence that is true or false is called a statement. Okay? All right. The next kind of statement that I want to cover with you is called a conditional statement. Okay, so a conditional statement is a statement that says if one condition is true, then another condition is true. Okay, that's called a conditional statement. And by the way, let me point out something. There's some clues to tell you that you're looking at a conditional statement. If you see the words, this is not 100% of the time, but I'm just saying very, very often, okay, you will recognize a conditional statement by seeing the words if, then. When you see if, then, you almost certainly have a conditional statement. Okay? All right, so let me write a conditional statement for you. How about, here's a simple one. If a car is blue, then it is not red. Okay? That one happens to be a true statement. Okay? Let me write this down here. this is a true statement. I mean, I know you might say, well, what if part of the car is blue and part of it's red? Okay, again, let's not split hairs at this point. This is only the first lecture. Okay, so let's keep things simple. Let's assume that cars are only one color, and if it's blue, then it can't be red because it's blue, and blue is not red. Okay, so this is a true statement that claims that if one, I'm going to scroll up, okay? If one condition is true, and in this case, that's the condition of being blue, then another condition is true. And what's that other condition? Being not red. You might say not being red, you know, but or being not red. Same thing in my mind. Okay. Do you see how that is? And look at the key words there. If and then. Those are the clues for a conditional statement. And by the way, looking back at universal statements, there's a clue for universal statements too. If you see the word all, that almost always tells you you have a universal statement. Sometimes it's the word every instead of all. You agree that statement up there would be the same if I said every car is blue, right? So all and every indicate universal statements. If then indicates existential statements. Okay? I'm going to pause for 1 second, so there's going to be maybe a weird sound in the video because I need to plug in my tablet or it's going to die on me. I'll be right back. Okay, I'm back. All right, one more. We're going to do existential statement. I said that this is the intersection of math and philosophy, and there is a branch of philosophy called existentialism. This is not that. Okay, this is a totally different use of the word. Okay, an existential statement is a statement that claims there is at least one thing for which a certain property is true. Okay, I'll give you an example. There is a blue car, or there is a car that is blue. Whoops, I misspelled it. Hang on a second. Okay, Now, let me say a couple things about that. When I say there is a car that is blue, I'm not saying that, picture somebody that's pointing to a car and saying, there, right there is a car that's blue. That's not what I mean. I mean, there is a car that is blue, meaning there exists a car that is blue. Okay? I'm not pointing to it. I'm just saying that one exists. There is one. Okay? And that is actually the key words for an existential statement, is when you see the words there is. It doesn't have to be those words, there is. Could be instead there exists, or, I could say some car is blue. That's an existential statement. Okay, but usually if you see the words there is, then that's a hint that you have an existential statement. Okay? So let me explain that here, why that's an existential statement. This is a statement. It happens to be a true statement, right? Or it could be false. Maybe I didn't know this, but while I was sitting here in my office, maybe every blue car in the world was destroyed, and maybe there aren't any blue cars anymore. So it could be false. But the point is not whether it's true or false. The point is that it is either true or false, and that's what makes it a statement. But I'm comfortable in asserting that this statement is in fact true. I do believe that there are still blue cars in the world. Okay, so it's a true statement that claims there is at least one thing. What kind of thing in this particular case? A car, one car. Okay. A true statement that claims there is at least one car for which a certain property i.e. being blue is true. Okay? I'm going to shrink this down so we can see all three of those at once. Universal, conditional, and existential. I hope it's not too small for you to read. And I want to point out something. Universal statements and existentialist statements can be juxtaposed with each other. Do you know what that word means? It means contrasted with each other. Okay, they're not opposites of each other. So I'm not going to say that a existential statement is the opposite of a universal statement, but they are contrasting in this particular sense. Look at those two. All cars are blue versus there is a car that's blue. All cars are blue versus there is a car that's blue. You see how those are contrasting in this particular sense. The universal statement is, it's taking into account everything, right? But the existential statement is only taking into account one thing, you see. So they're not opposites of each other, but they are sort of on opposite ends of the spectrum. Okay? All right, just a little bit more now. Well, I don't know. Actually, maybe this would be a good place to stop. Yeah, let's stop here, okay? I was going to show you that you can put these together and you can have something like a universal conditional statement, and you could have a conditional universal statement and things like that, but I think we'll save those for lecture number 2. Okay? So, watch this lecture as many times as you need to wrap your head around it. and then we'll have the discussions in Zoom for you to ask questions. If you have a question, then pay attention to which point along the video it is. The most helpful thing is to look at the little clock so you can say, I had a question at 10 minutes and 12 seconds, because then I can go right exactly to that point and see what it is that you have a question about. Okay, have a good afternoon or night, whatever. I don't know when you're watching this, but I'll see you later.